using the example of a drone. A control system is basically a collection of mechanical and electrical mechanisms that operate together to provide a desired response. A quadcopter drone consists of 4 rotors attached together in this fashion. The rotation of the propellers generates an upward thrust. Each individual rotor's speed can be controlled independently, thus paving the way for accurate direction control. Many different sensors are required to measure the drone's position and orientation. Some of them include an accelerometer, a gyroscopic sensor, flight cameras, timers, and so on. The drone can achieve translational motion in 3 axes, and it can rotate in 3 dimensions: roll, pitch, and yaw. Let's consider the scenario of a drone hovering. Your aim is to keep the drone hovering steadily as shown. For a drone to hover in the air, the upward thrust must balance the downward pull of gravity. Additionally, the net torque should be 0 to prevent it from spinning. That's not all. The translations and angular velocities in all 3 directions also should be 0. Let's see how the control system is applied in action. This drone was hovering in the air happily when suddenly the wind blew and the drone tilted as shown. The drone's smart controllers have to get the drone back to its normal angle, but the question is how? Let's freeze the scene at a particular time when the wind is blowing. Here, we're considering a change in just one angle for simplicity of analysis. Using a few sensors, the drone can measure its speed of rotation, its direction, and its angle. The sensors then feed this data back to the system. The angle theta is the error with respect to the horizontal axis of the drone. In order to successfully reduce this error, the propellers should produce a torque opposite to the angle. When the left and right blades spin at different speeds, the propellers will produce a different force and torque. The controller has to find suitable values of propeller forces throughout the restoration process. You can see that by the end of the restoration, the propeller forces become equal. Using a simple force analysis, the forces that the left and right propeller pairs have to produce can be connected to the angle as shown. Don't worry if you